keep x and y for length times width, but now z gets replaced with 12 minus 2x minus 4y. And now we have something that's detestable. All right. So our volume function. Let me go and maybe I think I'm going to distribute that out. That's going to be grenade reaction on that one. 12xy minus 2x squared y minus 4xy squared. So same paradigm. You've got a function that models the volume in terms of a generic xy coordinate in the domain of the plane and a specific z coordinate that's on the plane. And so this is guaranteed to be the volume of any box. If you plugged in x equals, say 4, y equals 1, z equals whatever, or well, x equals 4 and y equals 1, it only depends on x and y. It would tell you the volume of that long skinny box we looked at earlier. If you plug in x equals 1 and y equals 1, that's going to put you up here to give you the volume of that taller, narrower box, okay? But we're looking for the one point here in x and y, and therefore that point in z, that gives us the biggest possible box of all the ones that we can generate with this scenario. So, critical ones. First, partial with x and y are needed. Get my CPs.
You have to do them out.
Oh, sorry about that. So my first partial with respect to x is going to be 12y minus 4xy minus 4y squared. So, sorry folks, not linear. And then v partial y is going to be 12x minus 2x squared, y goes to 1, and then minus 8xy. Oh, and of course, we want to set both of these, force both of these to equal 0. Okay. Both have 3 terms. Both look kind of like a hot mess. But there is some, the one thing I see is if I take any one of these 2 equations, there is some factoring you can do. And that factoring will lead to 2 possible cases you could consider. Now, you may not have to consider every case. What are the stipulations on this function? For example, what's its domain for x and y going to have to be?
0 and
I was thinking
You should only consider values of x and y that are positive. So if you get a critical point that leads to a negative x or a negative y, you've left the first octant, okay? And that should also be octant. For some reason it says quadrant. Sorry, that's a typo. Anyway, since the first octant is the implied domain for this scenario, you should only consider a positive x and y. So that may help us with our algebra, also help us in what cases we actually want to consider. So I guess without any kind of real method of madness, just take the first equation. The first equation is set to 0. I can factor out a 4y, and that leaves me with 3 minus x minus y equals 0. So it's factored. It's a 2-variable equation, but if it's factored, you can at least break it down into 2 cases. This first factor tells me y should equal 0. Now think about that. Is that a case I want to consider?
No.
Why not?
You
You want the biggest possible box, and remember what the role of y is. The role of y in our picture is this, one of the dimensions. If y goes to 0, your volume's gone to 0, so you don't want a 0 volume. As the only time you should get a 0 volume is if this point here is at one of the intercepts. So one of the intercepts is going to be one of your solution. So I do not want to consider the case that generates. So I'll write it down, but I'm going to say frowny face because it doesn't really generate much of a box. So the other case comes from setting the other factor completely equal to 0. And notice it's a 2-variable equation, but it's another case you might want to consider. For example, if you solve this for y, it does give you something that you can make a substitution with. Okay? Because what you want to do is you want to kind of marry these equations together. take the different case scenarios that you know to be true from the first equation and use them as substitutions in the second equation. This one leads to some kind of nil solution I don't want to consider, so I'm not going to use that one. That one might have some meat and potatoes to it. So if I take this and put it into my second equation here, replace every use of y, and luckily it's not squared, you've only got one use of y. Replace that y with 3 minus x. Let's see where it leads, okay? So if I make that proper substitution, that becomes 12x minus 2x squared, looks like it potentially is going to be quadratic, and then minus 8x, and then here's your replacement for y. Replace that only use of y with 3 minus x. So now we have successfully married those two equations. We took a truth that we got from the first equation and have made it a truth in the second equation to see, where it comes from or what it's going to do. So the equation we get it is quadratic, but you don't have a constant term. When you put this in standard form, you end up with a 6x squared minus a 12x equals 0. And keep in mind, any truth you get from this only comes from that. So for example, if you get a value of, x equals 1.5 from here, you go back there and that tells you y has to be 1.5 with it to get the two parts of your critical point. So substitute that in, you get a quadratic equation. There's two solutions here. If you factor out 6x, you get x equals 0, but again, big picture, what I want to do is x equals 0. I don't want to do anything. If we had a global domain for this function, that would need to be a viable critical point to consider, as well as this. But because of the implied domain in the dynamics of this problem, I only want x and y to be something positive from the first octant. So this x equals 2. So I'm putting a frowny face there. So x equals 2, smiley face, because that's going to lead to something that might work out. If x equals 2, what's the y coordinate that should pair with this? Yeah, back substitute to where it came from. Everything we generated here was solely based on this truth from equation 1. Since that's a truth from equation 1, and that generates this truth from equation 2, the two-dimensional coordinate, 2 for x, 1 for y, is the only critical point we really want to consider. Okay. Oh no! Shut up.
I was going to say it right before.
Hang in there. You aren't even looking at the clock. That's awesome. So critical point at 2, 1. I will be remiss if I skip the d-test. I mean, it kind of has to be your coordinate because it's really the only possible solution. But just to double check, we've got this volume function we made here. Let's go in and fulfill its d destiny. The second partial with respect to x is not that bad. It's only negative 4y. The second partial with respect to y is negative 8x. And then your mixed partial might be a hot mess. The mixed partial, fxy, is 12 minus 4x minus 8y, quantity squared. So therefore, at this critical point, thank you for waiting, d is going to equal negative 4 times y, so negative 4, negative 8 times x, negative 16, and then minus, let me crunch this out carefully, that's going to be 12 minus 8, so 4. 4 minus 8 is negative 4, but it squares to 16. So, you get a positive value of d, because that's going to be positive, well, 64 minus 16 is a positive number, most often. And then, in this case, this is vxx is negative. So that means for this volume function, this critical point sits at the top of concave down. You do get a maximum volume, v value, at those dimensions for x and y. So the question says, determine the x, y, z dimensions for the box. So the critical point, oops, hello, I don't know that. I didn't plug it in. You got the XY coordinates from the critical point. You need to go back up to here. So don't write that 1 down yet, it could be erroneous. You plug in 2 for X and 1 for Y in the planes equation, and that'll tell you the height, the Z dimension. 12 less 4 is 8, and then 8 minus 4 is 4. So actually the Z height should be a height of 4. And that's not too hard to fix there.
So 2, 1.
So X equals 2, Y equals 1, and the Z height should be 4. That's the unique dimensions of the biggest box you could possibly make there. Alright? Okay. Wow, that was flush with class time. That's awesome. We got the whole thing covered. Okay. So if you want to, stick with the textbook homework, but again, you know, I do have this sort of supplemental set of problems here. If you want to scratch the textbook homework and just do this, you can check the answers when I post them on D2L. Okay? Y'all take care. Have a wonderful evening, and I will see you Thursday night or soon.